One of the great changes made to our classical notion of time came in the early part of the 20th century with Einstein's special theory of relativity. With this breakthrough theory, he became the first scientist to show that space and time cannot be thought of as separate entities. Indeed, he argued persuasively that they are intrinsically linked, and therefore that it is only a combination of the two which will explain how events unfold relative to one another. You're familiar with many of the common laws of physics. Objects fall, things burn, force equals mass times acceleration. They are, of course, less intuitive natural laws. Let us consider, for instance, the interaction of two separate people, or as physicists would speak of them, two separate frames of reference. Can you imagine two such frames? As the observed velocity of one of these frames increases relative to the other, it will appear to the former that the time in the latter is actually passing more slowly. Conversely, it will appear to the faster frame that the time is passing more quickly than in the slower frame. That is, it will appear that time is being dilated or altered. To understand this notion of time, we shall consider an example. Let there be two inertial frames, S and S prime, where S is stationary and S prime has a relativistic velocity. That is a speed that is an appreciable fraction of the speed of light. Until further notice, you should assume that any velocity that we refer to is a relativistic one, and thus one where normal expectations will not necessarily be upheld. We can imagine that these frames are special train cars, each with a single passenger seated in the center of the car. Let us arbitrarily decide that the passenger in the stationary car will be Thomas, and that the passenger in the moving car will be Linda. The clever student might wish to know about the fine points of our method. Let us then make our materials and setup clear. Outside, dust, noise, heat, storm, fumes. Inside, all's quiet, comfortable, safe. Features include 4-post roll guard, space-age metals, plastics and fibers to isolate the passenger from noise, vibration and jolts. She dials inside weather to her liking. He pushes AM, FM radio or stereo tape entertainment. She breathes filtered, air-conditioned air in her pressurized compartment. He selects from an impressive range of best-selling novels in highest quality recordings. She has remote control over multi-ton, multi-hookups with control tower visibility from her scientifically ergonometric seat. Hers is a lush situation. For the purposes of our illustration, we shall wish to mark out the point in time at which the moving car passes the fixed car. In order to mark this point, we must take certain data. We will need to know, for instance, the distances the train cars are from each other at certain times, along with their relative speeds. There are, however, sorts of data that we needn't know. For example, we won't concern ourselves with who Linda is in particular, or what her dreams in life might be. This data may exist, but it is unimportant, in that it is well outside the scope of our current example. Researchers carrying out this experiment must use a technique for marking the cars that will do its work at the exact instant that they pass. To satisfy this problem, these researchers find it convenient to mark the cars with light signals, since light will travel faster than any other conceivable sort of signal. This was a bit of information about the methods of science. There will be more about the methods of science in further lessons, because the methods of science are really quite fascinating, as we hope you will conclude by the end of this course. Right. For the purposes of our experiment then, we will need some means of creating a light signal that can leave a mark on both reference frames. Not just any sort of light signal will do. For instance, we wouldn't be able to use the soft fluorescent light that provides general illumination in the tasteful dropped ceiling grids of today's kitchens. Such light would not leave the desired marks on the cars that we will be needing for our calculations later on. Incidentally, if you feel at all lost by this technical point of our explanation, simply trust for the moment that all will come clear to you in time. Two separate bundles of dynamite have been placed on the tracks associated with the moving train. As the moving car passes the stationary car, Thomas and Linda note that the two bundles are triggered remotely by a handy switch. After detonation, the light collides with the cars, leaving permanent marks. Review the situation in your mind over and over until you feel comfortable with it. Now assume that afterwards, by measurements, each initial observer could find that he or she was located precisely at the midpoint of the marks which were left on the cars. Many different possibilities exist in principle as to what these measurements might show. Let us suppose, for the sake of argument, that the exact instant that the moving car came in line with the observer, Thomas's car, he triggered the dynamite. The result we now wish to derive is Linda's detection of the energy from these events. We have just established that both Thomas and Linda were located at the midpoint between the explosions triggered, and that Thomas found the two explosions to be simultaneous, as would classically be expected. Would Linda find that in her inertial frame these events also occurred at the same time? That is, that they were coincidental. We will now introduce a common piece of scientific knowledge and then follow it by a scientific concept. The energy from the events takes finite time to reach Linda in the centre of her car, and during that time the car itself moves to the right by some amount. Hence Linda will observe that the energy from the dynamite bundle under her car's forward-facing wheels reaches her a measurable amount of time before the energy originating at the rear wheels. Nothing can travel faster than the speed of light. For the light energy to travel more rapidly from one side of Linda's car than the other, time for Linda must not behave exactly in the same way as it behaves for Thomas. In reference to his stationary frame, Linda's time is slower. The precision Swiss-made clocks surrounding her appear to tick-tock slower than those placed around Thomas. Her perceptions of the length of her car are squeezed by another relativistic effect called Lorentz contraction. Even her own biological clock seems to slow in relation to Thomas's, her body slowing perceptibly and falling behind. This amount of time is very small, almost infinitely small. What do you think of when you consider infinity? Do you see many things? Two separate events which are simultaneous with respect to one frame of reference are not necessarily simultaneous in time, length, or position with respect to another frame. If it were possible for Tom and Linda to compare notes, listen carefully. Tom would find the events to be coincidental, whereas Linda would not. Time is truly an imagined property, as much as a property of fact. Simultaneity is genuinely a relative concept, not an absolute one. Indeed, were they to switch places, the figures of Thomas and Linda would become indistinguishable. Why do you suppose such relativistic effects are hard to measure? And why is it that Linda no longer responds from within her car, though the experiment is now over? When measuring relativistic effects, always be sure to keep track of the units involved. Good science is built on a strong foundation of good data. If we seem to be getting too technical for you, we will appeal to you on a more heuristic level. It is important to realize that the laws of physics don't always reflect our everyday experience, just as it will always remain important to realize that myths, poems, and paintings don't necessarily reflect the normal relations of human beings. The figures presented are so often heroes or villains, not normal people, and thus their archetypal behavior cannot be held up as an exact mirror to ourselves or our culture. But let us return to our frame of reference. Certainly the meaning of our observational facts are not to be determined solely by Linda. Rather, we must consider our own facts. There are detailed proofs available in Einstein's field equations to govern specifics. You will forget them soon enough. But one day you will agree when you realize that, despite what Linda might report herself, we can advance contradictory facts of our own. A person may have their own opinions, of course, but in fact it is hardly possible to even talk in terms of a single reference frame, that is, one person. You can certainly imagine why it is easier to talk in terms of a dozen Thomas Linder pairs, or 1,000, or several million. These are modern or contemporary ideas about science, but they are becoming generally accepted. Some conclusions suggest themselves from this. You now know not to question an event that at first seems anti-intuitive. Thomas has the right to claim that he is truly at rest, that the events he perceives are, to him, explainable merely as the motion of Linda's frame relative to his. Nothing else regarding the situation can be proved or verified. Indeed, we can all consider ourselves at rest in relation to a moving world, the gun trigger pressing itself against our stationary finger until it discharges and we feel our hand jolted back in accordance with Newton's law of conservation of momentum. Does being a stationary reference frame strike you as a bad life? You let the other reference frames do the things you hate. You do the things you like. The other frames mow the lawn, shovel the walks, paint and repair, and do all the exterior maintenance. You cross-country ski, play tennis, perhaps studying the physics involved in the game, hike, swim or nap. Your frame is at rest, free from interaction with other frames. The home of the free. Einstein, do you remember him? He claimed that the only real way to be at rest in this way is to die. Perception, indeed, is not a matter of fact. So we see that we can interpret the same event differently depending on our particular position. Do you have a particular position? Do you have a particular position? We have not chosen a misleading example. There is no frame of reference from which you can make an intrinsically correct judgment concerning all actions and events that will occur in your life. It is perhaps possible, though, to reconcile yourself to the experimental facts. You will agree at least that there can be no criticism of our construction of the situation. In succeeding lessons, we shall look more carefully into these matters.